Good afternoon, everyone. This is Matt Sexton with the Florida Department of Transportation's CAD office here in Central Office. We've got Todd Holt and a number of our staff here from the CAD office. I'm going to go ahead and make y'all organizers here to do training today. And hopefully everyone received the link to download the data set. If you could raise your hand to indicate if you did not receive or were not able to download the data set from that zip file link. Okay, we got one person. One raised hand, two raised hands. We got two people. Alicia, I did send you a new link. I guess we could unmute some of these people.
Yeah, put them all on mute, Matt.
Okay, I'm just checking. I got.
Okay, we're gonna make this interactive. It's gonna be fun.
So what I'd like to ask everyone to do is go ahead and mute your microphone, if you would. I guess like if you have a physical mute button, I'm gonna go ahead and unmute you on GoToWebinar, so you will be able to talk. I'm gonna start with the people who have their hands raised. We'll start with Alicia. Okay, hang on. Oh, neat. Hang on. I can't unmute. There we are. Okay, great. Okay, so it looks like I can unmute you and you can mute yourself and things like that. So we have a two-way mute situation going on. I haven't done this on GoToWebinar in years. So did you get the new link that I sent you?
Hey, Matt. I did get it, and it's still not working for me.
Okay, the new link is not working. Chris, how best do you want to handle this?
Matt, do they have access to the, I guess, the training up online? Or do they have the training data set?
Will that work for you, Todd, if we just if we send that to them?
Yeah, if they can get the training data set, I'll just show a couple files that I did some things in, and then we can kind of walk through some
Which
of the
training
stuff
data set should I send?
Let's do the 3D modeling.
Roadway 3D modeling, great. Okay, so I'm going to go ahead and send everyone, I'm going to put this in the chat. So if you've had trouble downloading the files, go ahead and check out the chat.
And this will kind of give us an idea for, I guess, for the next times too, because these aren't going to be your normal trainings. It's not going to be reading from the book. These are kind of ad hoc. So these are topics that you guys came in. I would like it if it's going to be boring for me if I'm just talking to a screen. So I'm going to ask for audience participation if you have questions for your current projects. And you want to bring those to these. We'll have these sessions, and then we'll also have kind of a follow-up session too that will kind of walk through. But the more interactive you guys or the questions you have, that's going to kind of allow me to help you and kind of that. And don't be afraid to share your screen if we get stuck. I'm not going to walk through the online training courses. So I have a couple different things that I can run through and look through. The Bentley resources, some presentations that we'll have that will kind of go through that stuff, but I'm going to rely heavy on the users to bring questions that you guys have, and we can work through it. If we can't solve it here, we can always have that follow-up call, or we can get another call in there that you guys have. But we're going to kind of take a look at that. So this first one is going to be a learning experience for myself, kind of what you guys are expecting, kind of what the CAD office is expecting too. But I'm going to run through some things that I found useful. It will be in the workspace, FDOT workspace. We're going to use the training data set for the color project. So I'll kind of run through some of that stuff, but show you different ways for earthwork. But if there are questions that you guys have I'm not that familiar with how FDOT is, or the requirements of what FDOT requires for earthwork. So you'll have to kind of help me out on that. I'll give us some examples that I've thought about to show what we can do with earthwork and really what kind of controls how Open Roads Designer does earthwork.
Okay, Todd, I have a question real quick.
Sure.
Once everyone gets the data set downloaded, would you
Uh-huh.
step everyone through the steps of putting it in the correct location in the work set? Is that part of your curriculum?
No, they should already kind of know the work set and that.
Sure.
So
Okay.
if you
Does
need
any
that, you can do that. Yeah,
Okay, does
to
anyone
put it
not
in the
know
correct
how to put
location.
the work set in the correct location? Go ahead and raise your hand if you don't know how to put the work set in the right location. That means not in your downloads folder and not in your desktop. Okay, looks good. We don't have any raised hands, so I'll go ahead and mute myself and let you carry on there, Todd.
Okay. So do we need to give everybody a couple minutes to download the data set, have that in there, kind of through that? The first part of this is really just going to be kind of a presentation. So I have a PowerPoint that we're going to run through talking about earthworks and grading. If I go too fast, let me know. If I need to explain something different, let me know. Again, I like to have this as being interactive as I can, relying on you to bring questions in there. If you put it in the questions or in the chat or raise your hand, feel free to come off mute. If you run into something that you're not sure of, feel free to share your screen too that we put on there. So I just kind of ran through a couple different things according to the PowerPoint that we're going to run through. So the first hour of this is going to be PowerPoint talking about feature definitions, the meshes, and really how ORD is going to calculate earthwork. But if you guys have examples that you can bring, that would be great. If it's not here, if it's a project, we will have follow-up sessions that Brian scheduled and or the CADD office scheduled for next week. So we'll have this kind of the training questions and then follow up if you guys run through that, because this is going to be a lot of information coming at you. But again, if we can make it interactive and get those data sets, happy to share those files with you, happy to get the questions. There are going to be some things that I can't answer, but I'll do my best. If I can't answer them, that's going to be homework for me. That I'll get that and I can reach out to Chris in the CAD office, Mike, or whoever, Matt, and follow up that with the questions that you have. So again, these aren't going to be kind of the normal coaching sessions or just walk through the training guide. This is going to kind of be an ad hoc. So if you guys do have questions, feel free to bring them. If you do have projects, bring that in there as well. All right. So this is going to be earthwork and subsoil is the topic. So I'm going to run through a presentation. And again, if there's questions, don't feel like you're interrupting me. These are going to be recorded to go back to, but I'll help and answer those questions as we kind of walk through that. So, and kind of use this time too, if you need to get that data set in the correct spot for open roads. We are going to be in the 2023 workspace that we'll run into of FDOT, and I have their data sets. I did send a couple of files, but seemed like they had a couple. So I'm going to run through a couple different examples that we'll do. So my name is Todd Holt. I am a civil consultant with Bentley. Been with Bentley for about, gosh, what's been now three years. I'll do a lot of things, the online training, workspace development for different agencies throughout that Bentley deals with. We'll do user preferences or not user conferences and training, and then workspace development. We also do these coaching calls and help people with their projects and just help share the knowledge that we have to the users that use our product. Before that, I was with FDOT, the CAD office, for about 7 years with Chris and Bob and Matt and Vern and Mike and James. With there, I was a CAD support tech, so I may recognize some of the names on the call. Looks like there are some new names as well, but we worked on building the FDOT Connect workspace for the FDOT, from moving it to the SS4 to the Connect. So we were kind of in there in the implementation of it when we first were moving that Connect and the workspace over. Right. Before that, I was with Nebraska Department of Roads, so I moved down to FDOT to work on that. I was in the bridge office there for about 15 years, design experience. So overall, about 20 plus years in CAD that I've been running through and helping there out. But that's enough for me. And again, if we can make this interactive, bring those questions as we kind of fill those out, and we have that data set in there. So this is going to be earthwork, grading and meshes and subsoil. Again, I'm going to rely on you guys to ask questions as how FDOT does their earthwork. And we do have the CAD office on staff too. So if I missay something or mislead you somewhere, the staff, please speak up too, as we can get the most out of these trainings. All right, we'll probably run for about an hour and a half, 90 minutes to 2 hours, and then we'll take a break and then get back into kind of the hands-on stuff that we'll have. So just the quick agenda for this PowerPoint is we're going to talk about feature definitions, why they matter, and the volume options. We're going to run through some ways to model earthwork within our data set that we're downloading, and some examples files that I kind of went through. We're going to talk about existing features and substrata unsuitable existing, those design meshes. We'll also look at create, cut, and fill meshes, and we'll look at some ways to report on our earthwork and subsoil. We'll look at the end area volumes, and we can skip over that if that's not how FDOT does it, but at least we can kind of look at that. We'll look at that quantities report by name boundary. We'll do a quick review of some legacy tools, terrain to train, component quantities, our dynamic end area display, element properties that we're going to kind of look at. We'll also do a little bit of hands-on as we'll kind of build those and look at some of the tools that FDOT has and different ways to model things. Because at the end goal, it's really getting that, the project at the end of it. So it might not be a specific tool that we use in FDOT, because you guys know those, you already have those trainings that we'll have, but we're going to focus more on the features and maybe an alternative way to do things. All right, so let's look at feature definitions first. All right, so feature definitions, I always think of those as what we want to draw. So those will be our feature definitions, as we're going to do earthwork, so our cut fill volumes, maybe our design meshes, maybe it's a curb mesh, could be a guardrail, could be our asphalt meshes, sidewalk. Think of the feature definition as what we want to draw. And we can put on that feature definition such item types, such as our location and pay items. And I know FDOT has a advanced or more advanced item types for pay items that they put on those. So we'll kind of look at some of that as well. You can have your terrain display attributes are going to be set by the feature definition. But what's important for us at that feature definition level is going to be our earthwork classification. And that's really going to be the most important way we can tell the software what we want it to do, or make the software do what we want, by setting that volume option. So if we don't get anything else out of this presentation, or what we're going to run through, is the importance of that volume option property on our feature definitions for our trains and our meshes, because that's going to tell the program what to do and how to calculate that earthwork for us. Right. So at that level, let me see if I can point. So we have our feature definition, right? That's the what. Your feature definition is going to point to a feature symbology. Think of that as how. How is it going to look in 2D? How is it going to look in 3D? How is it going to look in cross section and profile views? Right? And also in the feature symbology, we can do attach annotation groups. And that's where we're going to set an element template. And then after that, your annotation groups have different annotation definitions, text flavors, text styles. We're not going to get into that too much today, but we really want to focus just on the feature definition and symbologies, right? And feature symbology, again, is how it's going to look. Within that feature symbology, that's going to point to our element templates. And the element template, think of that as the why it looks that certain way, or the why. Why is it annotating this? Why is it on this level? Why does it have this terrain display? Or why does it have the CAD standard? So the level, the attributes of that material symbology, right? So that's really how everything works in ORD. Is feature definition is what we want to draw, or the elements that we want to draw. That's going to point to our feature symbology. That's the how it's going to look. And then the why for me is the element templates. So that's going to point us to our CAD standards, such as the level and symbology. Now there's other elements or properties that can be set in the element template for textiles, dimension styles, transparency, or materials. But we'll get into that. We'll save that for a later day on there. So those three are probably important too, but we're really going to focus on the feature definitions that we have that we're going to take a look at. So any questions on that? Does that make sense to everybody so far? All right, so we're going to take a look at terrain volume options, right? And those are already set from the CAD office within the workspace. So if we would look at properties of a terrain feature definition, right? We're going to have a terrain property, our volume options, and then here's our feature symbology that's looking at. For our terrains, we can have 4 different types of volume options. We're going to talk about design, existing, none, and subgrade. The ones that we use for our existing terrain is going to be the existing of how they're set up to. So that's going to allow us to compare a design mesh to an existing mesh. And from those two, it's going to compare that design to that existing surface and give us our cut and fill areas on there. So as we see here, design, it's used to create our cut and fill volumes, to find 2 design surfaces. Existing, those are is going to be what our existing terrains are set to. And that's going to be existing surface, and that's going to allow it to compare those. If we set that volume option to none, it's going to ignore that surface when we're trying to compute those fill volumes. And then subgrade, that's a legacy that was used in inroads. I know FDOT, you're a geopack, so it's different criteria. But that's a tool open in our inroads that compares a surface to surface volume, and it's treated like design. So if it's an existing terrain, that's going to be set to existing. If it's a proposed terrain, such as maybe it's a top surface or top mesh or bottom mesh, that might be set to design, and so we're going to use those to compare. That's kind of the start of just the terrain volume options as we kind of walk through. Once we get into our components or the mesh volume options, that's where we have more properties or more categories that we can set to. That's what we have here in this slide, is we have the different mesh volume options or a sample of those. that our feature definitions carry. So these would be things like our mesh components in your ITL file, your surface templates. They're either going to be set to design or existing, or we have none, the subgrade, substrata, cut, fill, unsuitable, and custom. Most of the ones that I looked at in the workspace are going to be our design components for like our proposed feature definitions that we use. There are some, such as your existing, that are set to existing meshes. We could use those, but I'm going to show some alternative ways to think about and build some of these templates out as well. So there's more options here, but we're going to set things to design, existing. If it's none, that's going to ignore computing cut fill volumes. There's our subgrade. So we have the same ones that we used for the terrain, but then we have some extra that we're going to look. So we have our use and utilize. We have our substrata, and that's going to define a substrata layer material for a mesh. And think of that as something that we can build on. So maybe that in the example that we have in here, that's going to be, maybe we have an existing pavement that we need to quantify for and set that. So we want to keep that and build on top of it, or maybe we're doing a widening type of project where we're tying into our existing roadway and doing a saw cut. We're going to set that to a substrata so we can build on top of. That's still going to create the cut and fill, but it's going to leave that substrata out, as we'll kind of see later on in this presentation, and then as we kind of work through some of our different examples. And then we also have our cut and fill, right? Those are going to be set to our cut mesh and our fill meshes. They're not going to do the design components, but that's when those meshes are going to kind of get created. When we compare a design to our existing? And then if we compare those, we're also going to have our subgrade, a substrata. The last couple are unsuitable. So that's maybe be something, or it might be something that we want to account for, but we need to remove that and not reused. And then we have custom. It's the same as unsuitable, but we can put that in our mass ordinate session or mass ordinate diagram. Don't think FDOT uses a mass ordinate, but over in the Midwestern states where they have more vertical change, they need to balance out their earthwork. So that mass ordinate allows you to create cut fill volumes and balance out your cut and fill throughout your project with your cross section. So you know if you need to have a borrow pit, or if you're going to balance out the earthwork that you're taking out into different areas. And really that's what we want to think about within earthwork, is think of it just as dirt and what we want to do with it. Where do we want to put it? How do we want to use it on our particular project? Because really that's all earthwork is, or if it's a substrata or that material. So it's just how we want to use it and how we are going to account for it in our project. Right. And we're going to start simple. So we'll just do cut and fill. So this is just a simple template that we have here. So this is our existing ground. Everything in our template, those are our design components. So what it's going to do on the next slide, if we run through and create our cut and fill definitions in our tool that we're going to use later on to create the cut and fill volumes, we'd set our feature definition for our cut, our fill. We'll talk about the unsuitable custom substrata a little bit later on and run through a couple of different examples that we have. But that's going to compare the bottom of this design surface to that existing ground. And that's going to create your fill from the bottom of the design down to the existing ground. That's all going to be fill because we need to fill that up to put our design template on or design corridor on. And if it's below or above that design surface, that's going to be our cut. So we need to cut down so we can put that into our design surfaces, right? So that's really how that's going to work. But we may have some different areas where we want unsuitable material or a substratum material that we have in there. So if we look at our mesh volume options, again, that mesh volume, that's really what's going to tell us to look at our volume options. So that's going to be the most important thing, is what this volume option is set to on our feature definition. Right? So if we want an unsuitable material, something that we need to remove. If it's set to existing or design, we're not going to get that material, but maybe we want to account for that. Maybe there is a existing payment that we need to take out completely and remove. We can set that to unsuitable, and it's going to take that. We can quantify that in reports and look for that in some of the reports that we're going to run through a little bit later on. Right? So we have our split. If it's set to false, it's going to be unsuitable. All that material is removed. Also on the unsuitable, we can split or not split it. So if we split, that's going to be on our next slide. Right? So if we set our split option to true, all that material is removed, and we'll see that it's over here as we're removing that material. It's removed, and we need to replace that material, bring it into with material that needs to replace it. This gives us a way to quantify that material and put it on a certain feature symbology so we can model it. Because we really want to think about how we're going to model that existing features, right? Because the model is going to be at the end of the game, that's going to produce our plans. That's going to be our deliverable down the road in the future. And we're going to give that into. Right? So we're going to set that unsuitable for using that. If we set it to true, we can apply a cut factor. So the shrink or the swell if it's cut or fill. If it's set to 1, that's not going to factor that in. But then we can have a feature symbology that we're going to use to remove and replace that material with, or just replace that feature symbology. That's what this is kind of showing, is we're going to remove this existing payment, but then we need to replace it with something suitable for this project. Up here where our design components are going to take the place of this, we just need to remove that material. So we want to set that volume option to unsuitable. And here's just an example of our cut and fill plus unsuitable. So here we have our design. Up above, that's our corridor. Those are all design surfaces. And down below, here we have, maybe it's a shoulder existing pavement that we're going to consider as unsuitable and needs to be removed, all right? So the only thing different that we're going to do this time around, when we're creating our cut and fill volume, these are going to already be set on the feature definitions. We may have to set some of these feature definitions to that and that mesh components, and we'll run through some of the scenarios. But to compute our unsuitable, we're going to toggle on this little checkbox and run through this tool. And we'll do a little bit of hands-on to do that. Right? So that would calculate our unsuitable and take that out. And what that's going to do is it's going to take that unsuitable that we marked here, it's going to treat it as cut, but there we can have this on a feature definition that we can see in a report that we account for that unsuitable material. Right? So it's going to be unsuitable cut, and it's not going to be included. So we're taking that, it's something that can't be replaced. We're going to take that out, and we're going to replace that with a suitable fill material. So it's going to go down to that bottom of those unsuitable. And then that's all going to be fill that we bring back in when we do our cut and fill volumes within there. Right, does that make sense to everybody? Get a hands up, any questions? And we have, okay. And again, if you guys have questions, put them in the chat or come off mute. You can do that as well. All right, so the next one that we're going to talk about is a custom volume option. So we might have a custom volume option that we want to use. That's going to be treated like unsuitable, but that's going to allow us to remove all that material if we do the no split, right? Because we might have something that we need to replace and use that custom. If we do our split, so we'd set our split here to true, that's going to give us the same options on our split as materials removed and replaced. So we'll bring that back over here. The only difference is we have a cut factor and fill factor that we can factor in for that material that we're removing, and the fill factor if we're replacing that. And we can set feature symbologies on those. The only other difference in this is a custom is this can be included in our mass ordinance. So if we need to quantify that or how it's going to be quantified to bring that material back or move it off somewhere. So that's really the only difference between unsuitable and custom. They're pretty much the same. It's just that custom can be included in the mass ordinance diagram. Right, so here's an example of a custom that we may have. So in this situation or this template, we have our design components. They're above our existing ground. Here's our existing ground. We also have maybe a wall that's a design component. But to build that wall, we need to excavate out below our existing ground, and then we need to build back or bring some of that material back in or that we want to quantify for that. So that's going to allow us to take this out and bring it back by setting and using that custom. When we create our cut and fill volumes using our create and fill cut and fill volume options or the tool, we would just toggle on this compute if we have our compute custom, if we had a custom component or a volume option set within our template or on those. So that's going to allow us to cut those out and bring that back in. Right, so what that's going to do is everything below or the existing ground, it's going to be removed. Up above it, it's going to be removed and replaced with a suitable material back up to that design. And then that's all going to be design or a fill material from the existing ground back up. It's going to create the design feature as cut that down and bring that information up. Here's our fill that it's going to bring back. Okay, so that's really kind of the core of it, of unsuitable and custom. So it's just how we want to quantify that. How is it going to be used down the road in our project? So the next one that we're going to take a look at is going to be our substrata. So our substrata, compute substrata. So, and this is kind of what we're going to base off some of the exercises that we'll run through or examples that we will run through and build those components out. So in this, if we had substrata, maybe we have existing pavement that we want to use because we're going to build on top of, or it can be used in place. So we have a project that we have that we're trying to mill and build on top of. We may have a saw cut line that we're going to use and widen out a particular project. We're going to set our volume options and our existing pavement to substrata. And that's going to be used in place to build on or tie into. It'll allow us to compute in our earthwork how much volume that existing pavement has on there. So in this example here, it's going to keep this volume option that we're going to use. It may also have a saw cut line because we may have some unsuitable material that we need to remove if we're saw cutting in that. Because if we're widening out a project, we're going to have to tie back in using a saw cut line. That's the next couple of slides that we'll run through has that example, and that's what we're going to base the examples that we'll kind of walk through with the hands-on kind of walking through that information in there. All right, so if we set our substrata, it's ignoring the substrata because we're going to build on top of that. But everything below that existing ground is going to go down to the design surface. But then that's going to go down around that substrata because we're going to use that in place. So it's going to create that as cut, and then we can fill that back in within our substrata. All right. It knows that we have some substrata material that we look at here for our mesh. We're going to set that volume option to substrata. We're going to replace the volumes unsuitable removal, and then we can include that in there. So it's going to mill that down or take some of that substrata to be removed, but then we can build back on top of that. That's really going to kind of fall into like your 3R jobs that you think of. And that's another session that we'll have in the future, is looking at the templates for the 3R, our milling and overlay and building that out kind of, and building some of that widening information out that we have. Does that make sense to everybody? Any questions on the mesh options, those volume options, unsuitable custom substrata? Everybody okay? All right. So let's take in here and let's think about modeling for earthwork. What are we going to do in our project? What does our project consist of? Right. So when we're modeling for earthwork, we're going to think about that design, but we first need to look at the existing features. And I know FDOT has their existing features tools for the existing conditions. Those are great to use. It's kind of the same methodology. But if we have a saw cut or a widening, we need to look at that mesh component because this is going to fall for both of them. The alternative that I'm going to show is I'm going to create a milling component for my existing features. I'm going to let the model do that instead of using the feature definition tools. But the volume options would be the same, need to be set the same for those shapes, because we can create shapes, we can create a terrain, we can apply a surface template. On that surface template, we're going to take a look at that mesh component and what that really needs to be set to help us calculate that earthwork. All right, so we're going to look at existing. On the next slide here is just a couple things to think of. Is think of everything inside that project limits. And we want to see or consider if it can be built on top of or be reused as fill or material. So think of everything within a project limits as just dirt. Simplify it, think of it as dirt. Can we use it somewhere down the project, or do we need to excavate it and take it out? We can't use it. Right? And the two options we're going to think about is, can it be built on? But it can't be used as fill feature, we're going to set that as substrata. If it cannot be built on or used as fill, then we're going to set that as unsuitable to allow us to compare. That's going to give us that earthwork. All right, so our existing pavement, sidewalks, curbs, pads, and maybe we have topsoils or clay, or even a muck area or undisturbed area that we may have. We need to quantify that and show, well, maybe that's unsuitable, that we can't use it, but we need to remove it and replace it with another material that we have. When we do this, right, or this examples that we have, we can do it in multiple files. You create corridors on your templates, surface templates. We have the create closed mesh tools. And one of the handouts that I did give within here is the Bentley examples for quantity earthwork. It'll run through a lot of some of the different areas, but it's not in your workspace. We're going to run through some examples in your workspace, but it is a good reference to have as well for you guys. All right, so think of just an example as we have a resurfacing and widening project, or maybe just a widening project. We may have some existing pavement to model. Maybe we have our existing shoulder that we're going to cut out. We have a saw cut line that we're going to tie it back into. All right. This example that we have here is kind of what we're going to walk through examples. But if you guys have examples or current projects, feel free to bring those in as well, or bring those up here if you want to share your screen. We can take a look at that. But for what we're going to do here is we're going to resurface and widening on the US 98, or maybe just do a widening part of it, right? So we have our existing pavement that we're going to use. We're going to model that out with a milling component. We're going to have our saw cut lines that we'll have here and here. So we're going to have some substrata to use, but we're also going to have possibly an unsuitable material that we need to take out and replace. We need to change those features, definitions, or model it a certain way. So we're going to run through just that practice of how to do that in some of the examples that we have. Right, so if we think of resurfacing and widening, we're going to have our US 98, so we need to do a saw cut lines are existing. So this is what our template looks like that we're going to put in here. And this is just a small area that we have on the example. So this is the start of US 98 and the old State Road 61. Everything within the purple shape, we're going to set to substrata. So that's going to be our existing pavement that we're going to use in place and build on top of. Anything outside of our purple area, we're going to set that to unsuitable, because we're going to remove that. But we want to quantify, we want to know how much unsuitable material that we're going to use. And then we're going to widen out some of that information in there. Right. So here's the same, it's just color coordinated. So existing pavement to remain that we're going to build on top of. We're going to be substrata, anything in outside of that purple area, and we may have a sliver on each side depending on where we're saw cutting that information to. We're going to set that to unsuitable so we can look at our reports and build that information out. And I know I'm sounding like a broken record right now, but we'll run through the examples in there. So we have a couple different videos that we'll run through and look at some tools. But that's what we're going to focus on, is kind of this scenario in our examples that we'll kind of walk through in the next hour or so. All right, so this video is just showing what we're going to kind of do. We'll get in more detail. So this is going to model that existing pavement out, and this is just one way to do it, is we're going to create a template to do that for. And I have a couple different examples and walk through building this. So we may have a milling component that we're going to use. I'm going to pause it there, and we're going to build this out as an alternative to using that existing features tools that you have. So this is just a milling component that we're going to build, milling or overlay or stripping. We're going to set this to the top option to follow surface and the bottom option to follow surface, but then we're going to give this a surface depth of 1. And then we can build that out to either be saw cut points, or maybe it's the end of our edge of pavement lanes that we're going to keep or saw cut. So we can model that out, we can build it out. There's a couple different examples that we have here and that I have with the data set that we'll run through, and we can build those out in the different scenario. But what this is going to do is we're going to apply this to our alignment for US 98. It's going to model our existing features out. And then we're going to make sure that feature definition, the mesh or the volume option, is going to be set to the correct volume option on that. All right, so this is just run through, and we'll run through this process of setting it up. So it's going to search for that existing surface, it's going to follow the surface, and it's going to give us a template depth or a mesh component depth of 1 foot. And here's just a simple constraint that we have in there that is going to be either 10 foot or 12 foot over. And then you could also put your parametric constraints within there. Right, so in here, I'm just going to attach my existing terrain and my geometry. And then I'm going to set my terrain as active as we know. That's going to create our 3D. We're going to push this template down, our existing alignment, and it's going to build that existing surface out. So we can set that to our final or whatever feature definition is set for our corridor, and it'll build that model out. Right, so we'll pick the template. That's just going to be our existing pavement. We have different options that we could build out, set our start and our stop, and it's going to build that information out in there. Right, then we should go to our 3D view. That's just a quick way to model, and this could be an alternative to the existing feature tools that FDOT has in there. Right, and I can use those to create shapes and kind of model that information out in there. Right, so the next episode or the next slide that we have here is we want to model out using closed shapes our unsuitable material. So again, we could use the mesh components of creating those or creating a clip terrain model out of there using that and the lines that we have drawn from our template or our existing survey information and use that to create closed shapes. And that's all we did here is we created a closed shape so we can set a terrain model and then a surface template to that terrain model there. Right? And within the FDOT workflow or FDOT tools, you have your existing features tools to do this. There's also training on that. So that's really all we're doing there is creating a clip terrain from our terrain model to do our existing features within that tool. Right, and when we're creating that clip terrain, we're going to do a flood to create the region. There's a trick to that is if it's not in the view, we can do a left click and then zoom out, and it's going to create that flood shape. Right, but there's training on that. You guys know how to create that existing features. Right, so now that we have both of those, we're going to create our clip terrain. We're going to apply our surface template to that and build that information out. Right, external. To our terrain model, we're going to create our shapes. So we'll select our terrain model here, then select our shape that we want to create that terrain model from, and then we can apply that surface template. But then in the surface template, that's where we're going to set that feature definition to be correct. So I'm going to pause that and move on because we'll run through some of this information on there. We're going to focus on the template part of it. Existing templates, if you're doing curves off of those lines, right? We need a profile for existing. We can set a template to that too. Run linear templates around there to model that out or model everything that we're going to remove. So maybe outside of that saw cut line, we have our strip of our existing pavement, but we also have our curve. We need to remove all that so we can build new or widen that out. Right? I'm going to skip over this because I think everybody knows how to do those linear templates that we have. Right. We also have a create closed mesh tool that we can use. That's a newer tool, I think came in 10.12. Was introduced is we can create a mesh and a shape. So that's going to be on our model detailing tab. Other ribbon under 3D tools, we create a closed mesh. This will allow us to create a closed mesh from a shape or from a surface down to a certain depth and define a feature definition on that. So it's another way we can create a mesh component. But again, the mesh component that we're going to calculate on is going to be, the volume option is going to be important. So allow us to create those. All right. This video here, I think I'm going to skip over, but we're just going to create a clip terrain and create closed mesh. Again, the tools that you guys have do that for you. So I'm going to skip over this one, this video here, but I can share this with Chris too. If you guys want to see that part of it, I can put it online in there. All right, so once we have our existing modeling and our proposed model, we're going to cut and create our cut and fill volumes and quantify those. And again, this is where I'm going to rely on the audience. Is how does FDOT quantify or create those? What's the deliverable that you need to deliver within your plans? So we're just going to run through the tools to do that in a particular file. So we're going to create typical workflow, as you guys may know or may not know. All right, we're going to create a 2D file for Earthwork that we're going to create our cut and fill meshes in there. We're going to reference in our files containing our terrain and meshes, the elements that we want to be considered in Earthwork. Our corridors, civil cells, ponds, our stockpiles, our existing features. So everything that we put in there, but one caveat of that is everything that we put into that file, if that mesh volume option is set, it's going to account for it. Even if the display of the reference is turned off, that doesn't matter. The software is going to look at it and calculate that. So if you don't want to have it accounted for, don't attach it. The other option, if there is something that you don't want to have it be calculated, we can set that volume option to none. And then once everything is in there, we're going to run our create cut and fill volumes tool, set the feature definitions. If we have an unsuitable custom substrata, we're going to set those as well, and it's going to run through and compute, right, that information on there. We'll run through some of that hands-on. So there's a couple of videos here. I'm going to skip over. That's just doing the same thing. I'm going to skip over that one because we're going to do that live in our session. All right. This is just an example of creating our unsuitable. We're going to run through that as well. So I'm not going to bore you with the video that we're going to run through this. All right, so we have some of that information that we're going to run through. We're almost done with the PowerPoint. I know it's pretty boring. And I know it is a lot of information to give to you guys as well. Reporting. So how does FDOT report, or what's required in the plans? So I'm going to look at a couple different ways to report. We're going to run through those in a demo, and as we kind of build some of our files that we're going to work in here in the next hour or so. All right, we're going to take a look at the name boundaries tool. All right, so we can create a report based off of name boundary options. So everything, again, we're going to reference into maybe a container file, or I think it's what the Qt DSRD file. We're going to reference everything in there. We can run different reports, create cut and fill volumes, plan. We're going to run that in there and create our clip graphics. Again, everything in that file we want to reference to, we would reference in our components, our model files, our Earthwork files. That will help us run a report to calculate that on there. And the reports that I'm going to show you are just basic. We'll have to kind of see what FDOT requires in there. Right, but we have our plan by name boundary volumes options. Right, and if we look back at here, it's going to spit out a report. And what this does is we can lay out a name boundary to mimic the cross sections at every 50 feet or 100 feet, or we can lay out a name boundary for phasing. We put it to the north or southbound or westbound or of our alignment, and we can think phasing within there. The PDF handout that I gave within the handouts category runs through some of those different scenarios. So use that as a resource too, or run through some of that in the next hour or so as we run through some of these different exercises. What that will do is it's for that name boundary or quantity by name boundary tool, we can simulate the end area volume. It's going to be more accurate. We can set those down. So here we can set the plan name boundaries linked to cross-section increments. We can get those quantities by the name boundary. It'll spell it out if it's every 50 feet or 100 feet. So there we have 100 feet. It's going to look at everything within that boundary and give us that information, help us quantify that information on. And if we're doing our mass ordinate, it's going to take out, give us a balance of that earthwork as we walk through those areas. Right, so here's a couple different things. It can simulate end area volume. It can simulate phasing if we have that in a project. We're going to run those quantities by name boundary if we have a name boundary. If we don't, we're going to get the entire project, or we can mimic our cross-section increments. That volume end areas, they're not going to match the end area volumes that we see within the project or within the dynamic cross-section. These are going to be much more precise in that calculation. How it's working and why it does it is it's a prismoidal volume inside the boundary. So it's looking at everything inside that boundary, and it's going to account and break that down within that boundary to mimic those cross sections. And it's not your average area in there. Right. That's just another video. that shows we're going to run through and kind of mimic that. Here's the example. We have our cut fill. We have our suitable material, our existing ground. We're going to do this hands-on, so I'm not going to bore us with just walking through this video here. Right. We also have our end area volume report that we can take a look at. I can skip over this if this is not the way that FDOT does it. We can skip over that, right? For the end area volume report, that's going to require cross-section name boundaries. Again, we'd reference everything into that file that we need, set that terrain as active. We're going to create the 3D, 2D. We're going to create our cross-section name boundary sheets, where we'll run through and create our cut and fill volumes here. And then we're going to do our end area volume reports after we have those cross sections. They can be associated to an annotation group for your cross sections. Some agencies do that. They have those. They're still using those. The last I knew, FDOT was just providing a report. This isn't a requirement on the plans. Right, but that's another way or another tool that we could use. Really, this quantities report by name boundary is probably going to give you the most accurate or the most beneficial. We do have our element component quantities and component quantities are some of the legacy tools that we'll take a look at as well. All right, this is just the video, so I'm going to skip over that of running that end area volume report. When we're thinking about our cut and fill factors and our volume options on the cut and fill, we're going to have that volume option, a cut factor or a fill factor. So the shrink or the swell is going to be associated with those feature definitions. So here we're looking at our volume cut, and we're going to set a cut factor for the shrink or the swell. So as we cut that, it's going to swell out 1.2 times, or when we put that back in, that fill, we need to compact that. So the material that we put back in is going to be more. So we're going to cut those out. So we can apply a cut factor or a fill factor to help us factor that information out, give us the volume, what that adjusted is, and the end in that end area volume report. This, we're looking at our feature definition for a volume cut. And again, the mesh property here, volume options are set to cut. That's our feature symbology. And we have the cut factor or fill factor. If it's set to 1, it's going to be what it's going to be. It's not going to factor in that, because anything times 1 is going to be itself. So if we have a cut or a fill, it's either going to be the cut, we're going to do a multiplier to give us more or less material that we're going to bring in for those. This is just an example of cross-section annotation that we can apply to the drawing model, that we can look from that report from our cut and fill. We can annotate those in the cross sections. Again, I don't think this is required for FDOT, or it wasn't when I was there, so we didn't create that. They just have that report that you can put in there. All right, almost done. We have some legacy tools, and we'll run through some of these as well. All right, some legacy tools that we have that are still in ORD is our terrain to terrain volumes, our component quantities, dynamic end area display, element properties, and then the measure volume. And we'll run through those and take a look at that as well. Right, so terrain to terrain volumes, we can analyze our volume terrain. We can do the method, right? We can do it to a terrain to a plane, or a terrain to a terrain model volume. So if we have a proposed to an existing, we want to get a quick estimate. We pick the 2 terrains that we're going to compare it from. We can save results. That'll give us that information that we place into that terrain. Right, great tool to give us a quick estimate that we'll look for. Right, and that can be found on the Home tab, the Model Analysis and Reporting group that we have in there. Right, we also have our element properties. So the civil quantities on the meshes, we can look at our volume, our planing area, the top sloped area. And here we have our shoulder aggregate that we have selected. We're looking at that property, right? Shows us our feature definition that we're using, the name. There's our civil quantities. So it knows off of that component the different areas in there. Right? It's displayed in master units, and our planular area, or the top sloped area, is we think of that as a surface that a drop of water may hit. So that would be this entire surface here is going to be this top sloped area. So what some agencies do is if they don't have a wedge or they have a wedge in here, they'll do another component on the top to get that top sloped area. So that wedge is not included within there. Right, we have component quantities that we'll kind of run through. I'll show those tools as well to report on. It can only do one corridor at a time, as we see in the dialog here. So we have our component quantities. We can set our unit cost. It doesn't recognize clipping. That's considered. So if we have a clipping element or we've clipped a corridor to another corridor, it's not going to recognize that. We can look at a report. We can set the unit cost. This can give us a quick estimate for what a project's going to cost. It does compute the cut fill, and it's from that lowest components that we use. Right. We also have our dynamic end area volumes, or dynamic cross sections, where we can come in our view properties and turn on our dynamic cross sections, or the earthwork, and get those. Right. So that's in that dynamic end area volumes. It's going to go from our lowest components. This is with no unsuitable or milling. If we do unsuitable or milling, it's going to go to the bottom of the existing that we're going to have in there. So example that we show here is that cut and fill in our dynamic sections. So the values in our dynamic section, they will be, this will just give us a quick estimate of what that's going to be. We want to utilize our cut and fill volumes. So if we want to get a quick estimate, we can turn this off and on to get what that cross section is. We can also review if that cross section is going to be valid, or if it's doing what we want to do when we're creating our cut and fill volumes. And then the last tool is our MicroStation volume tool. It's found on the measure. We have our volume options here that can be used as select and set. That'll grab that component. It'll give us the volume option that we have here. There's our properties of it. So mass properties, display center of the mass, and use our references. There we have, right, that display of those elements that we have there. And that is the presentation part of it. So is there any questions on that first part that you guys have? Are you guys still with me? Are you still awake? Do we need to do jumping jacks?
We're still here.
All right.
Yes, we're still here.
Did all that make sense?
Yes.
Did anything not make sense? Do I need to explain anything else or show something different on that? All right. So let me go ahead and here ORD, and let's walk through some of those things that we did. And did everybody downloaded a data set, but it's not Is it not the data set that I sent into, so you don't have those example models that we can walk through? We can kind of walk through that, just trying to get, oops, what we need to, so close that and the model. All right, can everybody see my ORD? You guys ready for kind of the hands-on, or is there anything from your projects that you want us to look at, or do we want to run through a couple examples of the modeling? All right, if you guys are going to be really quiet, I'm going to start calling out on you too. So, but don't be afraid to ask questions, because if you have it, somebody else has too. You know, this is a safe place to ask questions and get that. And you can kind of think of it as, you know, stump the Bentley person. I can find out, I can bring that back in there. So the example that we have, or that I'm going to look at, that we're going to build out, is the file that I have, and everybody can see my screen here, correct?
Yes, we can.
All right, so in this file, this is a Qt DSRD file, just an Earthwork, and I tested that. So here I have a little muck area, right? But I want to calculate that or set that feature definition. And I'm going to run through some of the features in there. So we have an area that we're going to account for and cut that and set those feature definitions. So what I did is I created a model named muck and brought that in. And, okay. All right. I also kind of came in here and so this is just that simple example of our existing. So this is a existing payment that I modeled, and we'll run through how I set up a template or corridor to model that out. And then I use from, I think it's from the examples, the example training, just the US 98, and just made that difference. So I have an existing payment here that I'm using as a milling, and I'm going to run through and quantify that. So this is kind of the end goal, to model this out. We're going to model out our existing payment. We'll create another model to help us model out our US 98. And then we can create a clip shape, and we can model out a clip terrain for, say, a muck area or a different area. Or if you guys have an example that you want us to walk through, right? We don't have, I'm going to run through this stuff, but if you have different examples, maybe a project that you're working on that you want to share now or next week as a follow-up, if you think of questions as we kind of walk through that. Right. So this is the end goal, and what I did here is I created our report. I then came in, if I look at my components, right, if I select on there, so there I have an unsuitable feature definition, and I also set a item type to quantify that. I create my cut and fill volumes, I turn those on. I also came into and modeled my existing payment off of the milling component, and we'll set that up and walk through that. And that's set to Substrata, so I'm building on top of that. And then I applied that template, and from that, I created my cut and fill volume option. So in this file here, since it's my QTSRD, I named it Earthwork. I go to my home tab here, I just ran through. I can create cut and fill volumes. That's going to give me my cut and fill. And then in here, I selected on those cut and fill volumes, and I applied that item type that we see. And hopefully this will show within this file if I bring up my properties. So this is the end goal. We're going to run through and build this out. Just a simple project to look at some of the tools that we can use. So there I have an item type that's attached to Earthwork. I also attached that Earthwork cut to the mesh components that we're going to build out for our substrata and the unsuitable. So it's going to calculate on those. So in this file then I ran my create cut and fill volumes. It's going to bring this up, set the feature definitions. I'm going to calculate my unsuitable, calculate my substrata. It's already in here, so I'm not going to redo that. But then at the end goal, if I hit escape, everything is set up. I have these quantified. I can then come to the F.dot tab and run my takeoff manager. I'm going to do my summary of Earthwork. I'm going to do my open output file and compute. I already had a couple of them because I ran through this just so I don't make mistakes. But hey, mistakes is how we learn too. So if there is something I'm missing, let me know. All right, so I'm going to click OK there. It's going to run through and create that Earthwork. And it's going to open up. And I did put some notes within there, but it's calculating everything in my model, right? And I can set those. So the pay item that I have are set to, it's going to calculate that information. The alignment's not found because I don't have that alignment information in there, but I can run in for regular excavation, my embankment, some of my subsoil excavation. And there I have two. So this is calculating my muck area. It's looking at that same, from what I can tell. I know James is on, or Michael, or any of the staff. If this isn't correct, let me know too. So this row 6 here that it's calculating is the same pay item number and the pay item description on there. So that's why I don't see a different pay item in there. But if I look at my design notes, here's my regular cut dirt, there's the fill, there's my muck area that's unsuitable, this is my substrata for pavement. So I filled that out in that area of inside those models that we're going to walk through and build. All right, so ultimately this is kind of the end goal of taking it from start to finish. We're going to end up getting to this output, right? And if you guys have other examples, let me know as well. So I can save that out, close that. All right. So the first thing that we're going to do, let's go ahead and create a model file for our existing. And let's see now, can we get some audience participation? Would anybody want to share of creating a file or kind of walk through this, or do you want me to walk through there? If you guys get stuck anywhere, let me know, right? Hopefully everybody knows how to create the file using the F.dot tools. Right? But if you're on a project, how would you create an existing model, right? If we think about modeling that we're going to do. All right, we're going to go to the F.dot tab, your actions group, create file. Everybody should be familiar with the create file tool design. We're going to go to our model. All right, within our data set. So this is going to be our model. We're going to model our existing pavement. And again, if I'm going too fast or if I'm missing anything, let me know on there. So I'm just going to pick my model, and I'm going to give this this will be our demo. Existing pavement. We'll do US 98. I'll do underscore. All right, so it's going to create that file. And please do follow along. If you get lost, let me know. If you guys want to share your screen too, happy to walk you through what I'm going to do here. I don't really have a training guide. This is just kind of off the cuff, just walking through stuff of what I would probably try and do on a particular project there. Right, so I'm going to create and open that file. And this first file, we're going to create our existing pavement. And we're going to do that from a template. We're going to create a milling component, as we saw in our video. In the data set that I sent, it has a couple examples on there, but if you've downloaded the other one, I'm going to walk us through how I set that up, or that information in there. Right, so in this file, and we could attach the survey reference. So we're going to need that. Basically what we need is our alignments and our existing ground. So I'm going to do a little bit different than the normal, but this would be an alternative to your existing feature tools that's on the FDOT tab or the survey. All right, so in this file, I'll go to the attach and my references. And hopefully everybody has in their roadway folder do you have an alignment RD or ALGN RD01 or 02? I'm going to use the 02 ALGN RD file. So basically we just want to get the alignment in there for the US 98 and the state road 61. So I'm going to reference that in. I'm going to go up to my project. And I just created a new one. You should have that. So just go up to the root. We're going to go to our survey. And I'm just going to attach my GDTM RD file that I have in there. I'm going to add that as well. So give a logical name for alignment and GDM just to help track. I'm going to put those in there. I'll do a fit view. Right. This should be just kind of muscle memory. We're going to set this as active. That's going to create our 2D and our 3D view. In our view 1, we're going to come here and turn off that level display for the 3D. Right. I do want to see my plan view and my 3D view. So I'm going to do a hard right click, go to view control and view plans 3D. So there we have our model, 3D model, and our 2D model. All right, pretty simple. That's all we're going to do. So now I'm going to go up and we're going to open up our template. Is anybody familiar with milling components in their templates? Okay. So one option that we can do, I'm just go to corridors and under the crate, we're going to go template, or you could do F12, I believe. We're going to go to our template. And within the file that I have, or my ITL, I have some extra ones. So this is kind of the same, or the same categories that we work through to mill out or create a milling component in there, right? So I was thinking when I was walking through this of how do I want to model out my existing features. I ran through the existing features tool. I also looked at the video that we had, the presentation. Is like, well, maybe I want to just do it by a corridor or have that be an option that I want to fill that out. Okay, so I'm going to come to existing pavement, So I can double click on that, and there's just a simple, that's what we're going to do. So we have a left saw cut line and a right saw cut line. And we're going to look at our component. So how I set this up is I just did a right click. This is going to be our milling and overlay component. We're going to follow the surface for the top. Our bottom option, we're going to follow surface as well. And we're going to give that a surface depth of 1. It's going to look for the active terrain model. That's going to help us model out that existing template. This is going to be our existing pavement. Right within our the FDOT workspace, we have a mesh existing pavement that's already taken advantage of. We can use that to help us know we're going to copy that feature definition and rename it and point back to that. All right, so we're going to take those and give it a different name and change our mesh volume options to help us calculate that information in there. All right, so does in our ITL file for existing feature templates, we're going to create a new template here. And I'm going to do a right click and a new template. And this will be our existing pavement. All right, so I'm just going to name that and then pave. And maybe this is our saw cut at 10 feet. All right, so we're going to create that saw cut line. That's going to be our blank template. Then we're going to come over here. We can right click on that. We're going to add new component. We're going to do an overlay in a stripping component that we have here. Right, and then after we do a right click over here, we're going to define what we want that component that we're going to build. So the current name, the name is going to be our existing pavement. I can't spell. Right, and then we're going to set the feature definition, and we're going to use that for now. Then we'll come back and adjust it. All right, and this might be something, or can be something that we want to think about of possibly adding to the FDOT workspace is have these extra mesh features that we're going to look to help us utilize for earthwork. So we're going to create a substrata existing pavement. We might create, or we're going to create an unsuitable existing pavement too, and utilize that information, kind of build those out. All right, so we're going to come in here. We're going to go to our cross section. We're going to go to existing. Then we're going to use our pavement asphalt EX. That's going to be our existing feature definition that we have. Right. Then our top option, we're going to follow surface. Our bottom options follow surface. The surface depth, this is where we're going to set that to what's a common existing features. A depth for pavement. 12 inches, 9 inches, 15 inches. Give me a number. Let's see, who can I call on? Let's see, Michael. What is a existing depth on existing pavement? Brandon, what's an existing pavement depth?
Let's roll with 12 inches.
I like it. I like it. Thank you. All right, so surface depth here, we're going to roll with 12 inches. as Brandon says, so we're just going to give that a foot. Right? We're not going to do anything else here, but then we're going to come in and we could go from center line and that, but we want this to all to be 1. So we're just going to place our points in there. So I'm going to place a point. We can place a point and we'll place another point there. We're going to come back and clean that information up. So after I have that placed, we're going to right click and we're going to finish. Right? Our component, if we double click on that, that's going to be what we just set up. So it's going to follow the surface depth of 1 or 12 inches. We have a bottom option and a top option. There are different options that we can use, and we'll learn or look at this more when we do the 3R project or the 3R training in about 2 weeks of kind of how to set some of this information up for the top option and the bottom options. We look at those, but we're just going to have it follow the surface for the top option. It's going to follow the surface for the bottom at a depth of 1. It's going to be on this feature definition. We're going to see what that feature definition is, and then we're going to modify that feature in there. All right. So we have 1 green point. What we're going to do now is we're going to remove our constraints. So I'm going to delete both constraints on our points for 1, 2. And then we're going to go to our first point or that middle point. I'm going to double click on that. This is going to be our CL. Right, so I'm going to name this CL. We're going to set our feature definition on this under linear, and we'll go to roadway design, template points. And we want this to be our template point null, so template null point, because we already have an alignment that we're going to base this off of, and that's going to be our PM that we're going to set. Right. We're not going to put any constraints on that, but we are going to give it a name on there. So we'll go ahead and apply and close. We'll go over to our left point or the leftmost point. We're going to double click on that. And this is going to be, let's get wild and crazy. This will be our left. And let's just say our saw cut and line. Right. So if we're building this out, we would want that to draw our feature definition to draw on this. So we're going to come in here and under our linear, our roadway design, our template points. This is existing. Right. This could be a pavement asphalt EM. Right, or we could put that to a milling component. So this is going to be our saw cut line. That's going to be our new pavement. So we're going to set that, and this one's going to be constrained from our center line. So we're going to set our constraints on that. We're going to go horizontal, and we're going to go vertical for our constraints. And then we want that to be constrained from CL. So we can either pick from the list, right, or we can click on the little target. We'll set or give us that target on there. We can go select that point. Right? And then we want this horizontally from CL. We're going to do, maybe we have a 10 foot or 8 foot. So we're going to do -10. And then vertical, we're going to set that to 0 because it's going to go and search for that existing ground. We just want it to be 10 foot from that center line. If we needed to, we could put a label for our saw cut left. So a parametric constraint in there as well if we want to control that. So maybe it goes from 10 feet out to 12 feet. Or we could use a horizontal feature constraint to have it search for a particular feature definition that we're using for existing pavement. Right. So maybe we put in our label here. This will be, I'm just going to do underscore, and this will be saw cut left. And I'm going to click apply. And now that moved, we have our naming on that, right? And now you can guess what we're going to do. We're going to do the same thing on that right-hand side. So we're going to pick on our point 2, right? Come in and rename that. And again, we're going to get wild and crazy. This will be our RT. Sock.
Hey, Todd.
Yeah,
Just a quick question. On the previous step,
absolutely.
when you were assigning the horizontal constraints
Uh-huh.
and you were just going through, there's a few different ways you could do it.
Mm-hmm.
If we're modeling existing pavement, wouldn't we almost always want to use the horizontal feature constraint because you're going to be looking something for a line in your survey?
Yeah, you could, or you can copy that in. I'm not sure if it uses existing. The last time that we ran through that, I think you copy your existing features in and you make it a linear feature, but you could do that as well, and as a horizontal feature constraint. So, number of different ways to run that. The only caution on that, if you do a horizontal feature constraint, is every time that corridor processes, it's going to have to go and search for those horizontals, right? The alternative to do that is you could create a point control, do the same thing. It's going to search for that horizontal. You do a point control on the point. So say we wanted our left saw cut line to look for a survey feature. Instead of doing the horizontal feature constraint, we could point it to use a point control on this point and grab that milling line or the edge of pavement that we wanted to look for. That makes sense? We can run, I can walk through it.
It does, I
Okay.
guess. So my experience, and I think probably, I don't know who all is on this training, but I
Mhm.
know for D5 in-house design folks that are on the line, we're used to using horizontal feature constraints. I
Okay.
think that's probably for most of them, as we're referencing those survey lines
Mhm.
and we're, say give it some kind of miscellaneous blue dash, red dash, whatever, and then we
Right.
set the horizontal feature constraint. The 10-foot horizontal constraint would just be an arbitrary kind of, maybe more or less where outside EOP or something is that we wanted to
Yep.
look for,
Yeah.
and then
Yeah.
just have it look for that line. That's what we're used
Yeah.
to. So
Okay.
if
Yeah.
there is a cleaner way of doing it that you're saying might allow our models to process faster, then I would want to make sure we go through that option as
Okay.
well, so they learn a
Yeah.
different way.
Yep. I can show that too. So, yeah. So if say, because you, and it sounds like you guys are pretty familiar with that, right? With here your horizontal feature constraint. So say we're going to look at, we want to survey, not do baselines or roadway design, plan profile. We got pavement. All right. So maybe it's a pavement milling line that we're going to base off. So we can set that up as well, right? Or whatever line that you guys are familiar with is we could add this as a horizontal feature constraint. By default, it's going to go 10 feet. But if that is, say, 12 feet out, then I want to build out the range that I want it to look for. So I would add another, say, negative 20 feet. So it's going to build an envelope that is going to look at, say, 10 feet. If I apply this, it's going to look at that 10 feet out to 20 feet and then move this point out to that. And that's what you guys are used to. I'm sorry, who was?
Yes. Yeah,
Okay.
it's Lori. So
No,
yes,
you're good.
that
Okay.
is probably the way that most of our people are
Okay.
building their existing feature model. So any other way
Okay. Yeah, we can,
would be
I'll run
helpful.
through, yeah, I'll run through another way and kind of
Okay,
show both of those. So the label and then a point control.
thank you.
I'm going to turn that off. Yeah, no problem. All right. So close that. And thank you for the input too. So we're going to do that same thing on our point over here. Right. So I already called the name. We're going to set our feature definition, roadway design, template points. We're going to go to existing, and this will be our existing pavement, EM, and then we could set these horizontal and vertical, come back from our point and our point, and this is going to be 10 feet. And we'll set that to 0 because it doesn't really matter the vertical because it's going to go hit that existing and move down in there. All right, and then the label, this would be our, say, underscore, just to put it at the top of the list, and then this could be a saw cut. I'll do right. Right, I'm going to apply and move that out there. So, right, and if we had, say, that's going to be our saw cut line. Another example that I had here, and I'll resend this to the CAD office, Chris, and the team there. So you have these example and kind of walk through those, or if you get that download on there. So basically all I did on, say, a next one is maybe I have a saw cut line, but then as we saw in that presentation, there might be a foot outside of that that's unsuitable, or we set that to unsuitable. So I could create another milling component. Right, let me just go on like this one, right? Because, and what this one here is looking is this, I changed this mesh component. So maybe I have from that saw cut another component, the same milling. So if I look at this, but this is a shoulder unpaved, or maybe that's a different depth per shoulder. Maybe it's 9 inches or 6 inches or 10 inches of a shoulder that I want to model out to. This would be another example of building that information out. Right. Just setting that, it's going to be follow surface for both my options, top option, bottom option. But then the surface depth is 9 inches. Right. So it's going to come in and it's going to draw that out as well. So, and then if I do a horizontal feature constraint or a point control, I can point it to a particular element that I have as I lay that out. So there's different options that we'll kind of run through and different examples. So this is just one way to do it, showing you some of the tools. It's just how, right, there's not a right way or wrong way. There's just different ways of doing it, because how I do it may be totally different than anybody on the call would model that out. Right. So now that we have this built out, I'm going to go to my center. I'm going to right click on my center. I'm going to change that template point origin. So I'm going to put that down at 0, 0 there. All right, so I just right clicked on there and template. So now it's going to place this on my baseline and draw that component out. So everybody get their existing pavement, the saw cut, and this is just 10. So I'll do this as, just name that demo. And I can't spell. Okay. So I'm going to go ahead and close this and save. It's going to save it. And now that I have these two different views up, I'm going to come in and I'm going to apply that corridor. So this will help me model that out. So let me come in here and corridor. We're going to do new corridor. And I'm going to set this to our final. Locate my alignment for US 98. I'm going to right reset, so right click, and that's going to be my US 98. And then I'm going to come in and select my template that we just made. So existing features templates. You need to pick the right one. So existing pavement saw cut. I'm going to pick that, and I'm just going to run that So we're going to set our drop interval, set that to 10. We'll do a left click here. We'll do this at, let's say, 18 plus 50 for the start. Accept that. Then we'll go out to, let's just say, 21 plus 50. So we'll go 300 feet out. And I'll left click through the prompts and build that out. Then I'm going to escape. And if I look here, I'd already turned off my 3D model, but if I look at my mesh, right, if we look at our cross section here, so I'm going to open up a dynamic cross section view, go to view control, do 3 views, plan cross section in 3D. Locate my cross section, locate my corridor, select my view, that's open. And there is our existing pavement. All right, that was modeled. So it's placing off the center line or the baseline of the US 98, drawing 10 feet out, drawing 10 feet out, following the top surface and bottom surface to give us a depth of 12 inches. As Brandon said, that's what we need to use to put that in. So that'd be one way to kind of model different elements out. Right, so that's just going to be a static 10-foot saw cut line that we would have. Right, so there we have that modeling. So now I'm going to look at my Explorer. How are we doing on time? We got a little bit of time there. So I'm going to take a look at what? What do I want to look at? What holds our volume option? What was our first part of the presentation? The Alex. Oh, come on, guys. Gabriella, you got a question? Where is the question? Oh, who's got their hand up? You guys are so polite. Who's got the answer? Anybody? Anybody? What do we want to look at next after we have our model that we have in there? What do we need to take a look at in the Explorer that holds our volume options? Go ahead, come off mute. Anybody?
Is it the feature definitions?
Oh, who said that? Who said that? I like it. Is that Brandon?
Yes, it was.
All right, cat office, Brandon gets a gold star. Matt'll hook you up. So yeah, so the feature definitions. So, because that's what's going to control how we're doing our quantities. So we need to look at that volume option. So now that we have that in this file, right, we're going to go to our Explorer. So that's going to be on our primary group. I'm on the corridors tab here. We're going to go to primary group. I'm going to go to my open road standards. We're going to take a look what's in the file. So that's going to be our model for existing pavement. We're going to look at our feature definitions. We're going to go to mesh. We're going to go to our cross-section category, so excess. We'll go to existing, and we're going to look at our pavement asphalt EX. And if I look over on my properties now, that volume option is set to existing. So if what we went through in the volume options, if we're trying to compare design to existing, or we want to account for our existing pavement, what do we want to set that to? Because if we set it to existing, it's going to just compare design to existing, and it's going to create cut and fill volumes. Anybody? Don't be shy. All right, I'll give you this one. So we want to change that volume option from existing. So I'm going to click on the volume option there. We want to set that to, what do we set it to? Design. Is this a design feature? This is our existing feature. We're going to build on top of it or use it in place. So we want to set that to substrata. Or maybe we want to quantify it and remove it. So we would set it to unsuitable. But in this situation, we're just going to set that to our substrata. Right? And then our cut factor, we can set that to 1. Right? So we don't have a pavement asphalt EX. So that's was set to existing. So what I did in my other file, so we're not overriding or I can model multiple things in here, is maybe we want to copy this feature definition and say, hey, CAD office, can I get a CAD standard to model unsuitable, my custom existing pavement, or unsuitable, custom, or substrata, right? In this, I'm just going to copy this and I'm going to rename it so it makes sense to me, right, in this. So in this file over here, I'm going to go back over to my Explorer. I'm going to right click and copy. We're not going to overwrite this. We have written this into the file. So I'm going to copy this. And then I'm going to do, this is my pavement asphalt. And this is going to be our substrata. And that's going to be EX. So we stay with that naming convention. We're just going to tell us what it is. All right, so now in this file, we have another one, and that's something that we could send into the CAD office as a standard. Can we get some of these extra layers to help us model our existing conditions differently so we can quantify those? Right, so I'm going to change my feature definition. I used one. I'm going to copy that and rename it. So I could come in here in the original one. I'm going to put that back to existing. So there's our original. Here's one that I copied. I'm going to set that to substrata because we're going to build on top of it. And then I'm going to go to my feature symbology because I don't have anything set on that one. So now I'm going to go to my feature symbologies level. And under surfaces, go to corridor components and pavement asphalt. That's going to point to element template. So this is, again, the what, the how, and the why. Right? So I'm going to copy this symbology as well. And I'm going to rename this to substrata. And then everything's going to go on this pavement up here, this element template that it's using. So it's going to be the same element template. I could go and follow up, and I don't have the ability to rename a level, but I want to utilize a level that already exists within the workspace. I'm just going to change the feature definition so I can model multiple things in this file if I needed to. If I don't do this, I would probably want to create a model for my existing pavement. If that's substrata, I may have to create another model for a different feature in there. But if I copy it in there, I can override in this file and have multiple levels in there. All right, so we've applied our template. We're coming in and overriding or copying and renaming to our substrata. We then want to come back up to our feature definition. and we're going to go to the asphalt substrata, and then we're going to come in replace feature symbology. We're going to set that to the symbology that we just created down below. So our copy, so we want everything to be, oops, no, we want, cancel all that. Getting ahead of myself. Oh, so we want to place our surface feature symbology. Right, so we want that to be our pavement asphalt substrata. And then our name seed on this, also want to come in and we're going to give this a name of substrata as well. I'm catching myself on some things that I probably didn't do that first time. Right, so we're copying that feature definition that already exists. We're going to model this out as our substrata. We're going to copy and rename that. If we had a replace feature symbology, we could set that into this as well. So maybe we want to come in here and set that to surface. We're going to go to corridor components, and we'll set that to our pavement asphalt existing. So we're not replacing that, we're just going to do it in place, but if we did, we would have that in there. So we're just going to make sure everything is set that same way. So we're just accounting for this existing pavement to be substrata because we're going to build on top of it. So when we do our modeling for our proposed, it's going to find that information. Right. So now that we have these built or the feature definition copied, we need to go back to our template. We'll go back to our create template dialog, and our existing pavement saw cut demo, we're going to double click on the component itself. We're going to change our feature definition in our component properties to find our new pavement asphalt substrata EX and apply, and we'll close. So we're going to override what comes in the original. We're going to replace it with what we have in this file. All right, so if this is something that this needs to be, sent back into like the CAD office. See, there's a question in the chat. Is it Gabriella? Did I lose you somewhere? Right, after I change that, I'm gonna click yes, close out, and then I'm gonna update my corridor and reprocess that corridor. So now I look at my 3D model here, and I do my element selection tool from my 3D model. If I look at my properties, it's about time for a break. It's still going to be on the same level as pavement asphalt EX, but if I look at the property of that, it's on the feature definition that we just created, and the name's going to be the existing pavement substrate as well. Right, so that's really what we want to do for this point. So that's modeling that existing pavement in there, right? And this is just the properties dialog is not showing, so I just need to get back into that file, right? So did everybody have their corridor? They have their new feature definition in the file? Anybody not get that or need to run through some of that?
Hi, I have a question. When I did the cross-section view, my pavement asphalt existing isn't showing.
Asphalt existing.
Like the blue dashed line.
Okay. Let's see. Do you want to share your screen?
Sure. If I knew how.
I wish I knew too. let's see. See, Matt or Chris, are the attendees able to share screen? See if they're paying attention now.
There should be a button once you're made presenter. So Todd, you may need to right-click and select Make Presenter.
If I make presenter, I'm looking at sharing. All I see is the organizers.
Okay. And who is it we're trying to share?
Kayla?
Is it Kayla? Kayla.
Okay. Huh. I guess we need to. This is interesting. Huh.
In your dynamic cross-section view, if you move forward, does it show up, Kayla?
No, I tried doing that, but it's not
Oh,
showing.
Kayla's connected via the web. We won't be able to make her presenter. If you connect to a webinar using the client software, that'll work. Unfortunately, GoToWebinar defaulted to the web a couple of years ago, and I fussed at them a number of times because it used to default to the client software. You have to force it to run the client.
So can we get that worked out for next time, Matt?
Absolutely. Well, I
Is
mean,
there a way? Oh, so you can't
I'll
change
have to
them.
write
Just
I'll have to write a white paper on how to do it. But if you go to gotomeeting.com, and I'm trying to remember exactly how this works, but like it gives you an option. It says there's a tiny option to download the client software, run it. Chris is typing something to me via Teams.
Can you make them an organizer?
Nope, because it's via the web.
Can't see any. Well, that's not very fun.
Yeah, unfortunately, we can't do that unless I only see a couple of people that are connected through the client.
Most of them are through, on the web.
One thing you can do is, I mean, if you log out and you go to gotomeeting.com and select download and load the client software and then launch client software and put in the webinar ID, then that'll work. Let's see, where is that?
Let's see. Kayla, did you set the terrain as active? Do you have an active terrain? Do you see a terrain in your cross-section dialog?
It's in the cross section, yes. But it's not actually set as active in the 2D.
Yeah, so set as active and then try and reapply that dynamic cross-section view.
That worked. Thank you.
Sure. Right. So, anybody else have any questions? Because I did promise you guys a break. So let's go ahead and since we have that, we'll model a little muck area after, but let's go ahead and do a break. Stretch our legs. I know it is after lunch. So let's go ahead and do 15 minutes. I've got 3:07. So come back at, let's see, Matt, what's a good time to come back to? 15, 3:25, 3:30, 3:20, 3:25. Let's call it 3:25. I'll come back. So we'll take about a 15-minute break and then come back. All right. We'll see you guys in 15. We'll probably give a 2-minute warning and then we'll get back in and move on to the next part of the exercise. Thanks, guys.
Thank you.
So what is the requirement for the earthwork for a project? What's the, I guess, required deliverable? Is it just still the report? Has that changed?
As far as I know, I think the requirement is still the EQR.
The EQR. Okay. Is that is just the overall report comparing the proposed surface to the existing surface? Is that correct?
That's the pay item report
That's the pay item report. Okay.
Right.
So I guess,
from the
what is
takeoff
the
manager.
EQR? The takeoff manager. Okay.
Yeah. It takes the summary sheets that are made in the takeoff manager and then combines them.
Okay. I have. All right. Well, I do have 325. Hopefully everybody is back from break. So give one more. If you could put your hand up or just come off mute and say yeah. We'll get going and continue on and kind of build out a couple more and then start building out our proposed model. I think everybody is good. Gabrielle, got a question? Are you good?
I don't know why it keeps saying that I'm raising my hand, but I am not. I promise.
Okay. Okay. Yeah, if you guys do have a question, come off mute. Just interrupt me. No problem on there. It's more fun if it is interactive. So, all right. So the next step I got back in just to see if my properties window isn't acting buggy. So it does act buggy if it's not showing the properties, because we're going to come in and from my 3D view, I want to select that and the property. So the next step on this is I want to apply an item type to this mesh. So I can quantify that at the end goal and add that to that summary. All right, so I'm going to attach that, and then we can kind of talk about some of the things that Kayla brought up with parametric constraints, point controls, and that external reference. And there's not a right way or wrong way to do it. There's just different ways of modeling. All right, so what I'm going to do now is I'm going to make my view 3 active, and I'm going to go to Utilities tab on the ribbon here, and we're going to attach an item type. All right, and I'm going to go ahead and utilize an item type that we already have established under the right-of-way quantities. Expand that out. I'm just going to do my earthwork cut and earthwork fill. All right. I did come in and try to create a custom, but I did find that it wasn't reading correctly, and I never did get back to James Griffith on that. So I'm just going to utilize what we already have, because everything is set up in there, the subsoil. So I'm just going to utilize what we have and apply the correct. When I was doing my testing, I copied this and moved it up to this custom. I don't know if that's the right way or wrong way to do it, but so I'm just going to utilize this roadway quantities. We're going to do our earthwork cut and earthwork fill. So everything's going to be put on there, but then we're going to specify in the notes what we want those to be or what we want to use on that. So if you do have questions on like the custom item types, I would run through the automated quantities training that we do. I'm just going to utilize what we have right now within the workspace under roadway quantities. So on my substrata, I'm going to come in and make my view 3 active, which is my default 3D. I'm going to go to Utilities tab on the ribbon, and then the item types group. I'm going to attach item type. And then I'm going to come into my roadway quantities. I'll expand that out. I'm going to pick on that earthwork cut. So this is already made up, so I'm just going to apply this element. So I'm going to apply that to my mesh component. I'm going to get the attached item, one item to that mesh component on there. So then I'm going to close that dialog. And then I'm going to come back over to my mesh component. for my existing pavement. This is built from the pick list. I'm just going to pick on that and utilize one of the item types I have. This is going to be subsoil excavation. And then in my design notes, I'm going to name this. This will just be existing pavement substrata. And then construction, I'm going to use in place, build on top. Right, just something in there so we can get those out. So that's going to help us quantify, right, that. Right, so there we have our existing pavement that we're using to model. If we had other components, we could do that in this file, the same process if we had a shoulder or that existing cut. Right. If I come in here, I'm going to go back to my view one. And let's say we have our survey. So let's see, I'm going to go to attach tools and I'm going to attach our serve RD. I know you could do it through on the FDOT tab on the ribbon there and attach survey. I've already kind of built out this, so I don't want to see if it messes with anything else. So I'm going to go back up to the root and I'm just going to attach this survey file manually. And I'm going to copy a couple of feature definitions or see if I can copy that in. So I'm going to reference in my survey. And I'll give this a name of SRV and apply that. All right, so what I have then is if we want to target this edge of pavement here, all right, we can do that with that horizontal feature constraint. Or we can do a point control as well, or do a parametric, right? So the process here is I would copy this in, or I would target this survey. The last I knew, ORD was not, it doesn't work well with the survey features. So I would copy that in, put it on the correct roadway feature that I want to use. All right, so that would be one thing to do that. So let's just pretend we came in and we copied this information in from the survey. We have an existing or external reference that we want to add to our template. All right, so I'm going to come back and I'm going to detach that file for now. All right, so say let's have on our left-hand side of our road over here. I'm going to come back here. Turn that off. So I just want my existing ground. I'm just trying to think what I want to do in that. So let's say we have a milling line that we want to target, or external reference, or we also have a milling line that kind of, it's not a straight 10-foot line that we're going to use. So I'm going to go to linear. I'm going to go to existing features and my existing pavement. And I'm going to do let's just keep it simple. We'll do pavement existing miscellaneous, or pavement miscellaneous existing, or let's do pavement asphalt existing if we want to target that. So I'm going to use this, and if I copy that in, or if I draw something there, I'm We can add it as external reference. We could also do a point control and target that element. So say we're going to come in and draw using that feature definition or copy and survey feature for our project. And that's going to run just outside of our saw cut line, or we want to target, but maybe it widens out right this way. We already built the labels into it, but we could add this as an external reference. But if it's this point, then it's going to find another point. This isn't too bad because that's not too long of a corridor or of a template. So we could go back to our template, corridors, and create. We're on the right-hand side. So I'm going to go back into the existing pavement saw cut demo. I'm going to turn on my horizontal feature. Our saw cut. There we want it to look for pavement existing from 10 feet out to, let's say, 20 feet. So we're going to build that envelope that we're going to have it search for. All right, 10 feet is going to be the default. But in addition to that 10 feet from center line, it's going to draw it this way. If it finds this horizontal feature constraint between 10 feet and 20 feet, it's going to draw that out. So it's going to go out in there. So it's building the envelope that it's searching for. Right, so we do that way. We could also do the parametric constraint we have there. So just go over a couple of different options that we have. So close and update. So if I go to my element selection, I'm going to go to my corridors. I'm going to go ahead and select my corridor handle. I'm going to go to the little hammer and parametric constraint. Let's do this way then. So I'm going to go up to miscellaneous and corridor references. I'm going to select my corridor. I'm going to select my elements as a reference. I think this is what Kayla was saying that they do on in District 5. Perfectly fine. So that's going to make this edge of pavement go from 10 feet and follow this feature definition. So I'm going to go ahead and select on that and then right click and place that. So it's going to find that within 10 feet, 20 feet of that center line. So it should follow that out, which it did not. So that's because I needed to come in and update and reprocess my corridor, right? So I made the change to the template library. So that's going to go at the start, but target that line. So in my model here, as I walk through, maybe that saw cut line is getting bigger. It's still matching. It's just following that feature definition, or this line as a horizontal feature constraint that we added in there. Right. If I go to on the other side as a parametric label, so say on the other side we want it to go from 10 feet to 16 feet from start to finish. There's a 4-foot transition or a saw cut that we want to follow that out. The other thing that we could do is our label that we put in there. When we built our points on our demo on this left saw cut line, we put it on both. But if I take a look at this one, we put an underscore or underbar saw cut left. By default, it's always going to be 10 feet, but we can use this label and parametric constraint to take it out from 10 feet to 16 feet. So we can make it more dynamic in this way by adding this parametric constraint or parametric label. So we're going to come in on our other side. We'll go up to the edit tools and edits. We're going to create parametric constraint. I'll locate my corridor. I want this to run from my start. I'm going to lock, right? I could lock the start. I could do the start and lock it in. So maybe I want that at 18 plus 50 to 21 plus 50. So I'm going to key those in, accept it. There's my parametric constraint, my left and right. So the start value, I want it to be 10, but then the stop value, let's make that 16 feet, or let's see, difference 18.5. Right? And then I'm going to move this out of the way. We're going to see this left-hand side get wider throughout there. So I need to check what that, but that's going to allow that not to be static and be a more dynamic template that I have within there. So that's a couple different ways to do that or control your template after you place it. So that's kind of the benefit of doing a template is we can control what we want it to do differently than we can a surface template. Right, so I'm going to come back and I'm going to turn those off. So if I go to my bucket under the edit group or the quarter objects or the bucket or the hot tub, we can look and see our external reference. Delete that guy. That side will go back to normal. Look at my parametric. I can delete that one and that'll go back to normal as well. All right. I could also take this and I can control this with a point control. And as a point control, it's still looking at that feature, but it's only pointed to that first point. So the other option that we could do is I could create a point control on this template. I want that to run. Maybe it's from there out to the end. I'm going to pick my point. So this is my right saw cut, maybe the control description that we have here. This is my saw cut line. I'm going to control it horizontally off of linear geometry. And then I'm going to pick my plane element that I want to control. And that'll do the same thing. I don't have to add that as horizontal feature constraint, but that'll target this horizontal geometry. Okay. That would be not a wrong way, a right way to do it, but a point control is going to be faster than that horizontal feature constraint because it's only looking at that point in the stationing that it's putting on. Go back to the corridor objects. I'm going to take that off. The point control, I can delete that. It's going to go back to normal. So those are some ways of making your static template with your constraints dynamic. You do parametric constraints, point controls, or your horizontal feature constraint. So now that we have this, I'm going to go ahead and, all right, so we're going to delete that guy. And we got 3, so just to save time and another method or to quantify another file or another type of unsuitable. So maybe on this project we have our substrata, but then the next item that we have is maybe something that's unsuitable. So maybe it's a muck area or something that we need to calculate and remove, right? So if it can't be used somewhere else, it's going to be unsuitable. We need to remove that and replace it with something that we need to, a better material within our fill. So to do that, just to kind of make it simple, we just need a shape or a closed shape in there. I'm not going to get too fancy because we already have your FDOT tools and your create existing features. we saw in the video, we can create those shapes and that. So I'm just going to do a simple and create a clip terrain. So for this example, I'm going to go ahead and rotate, and I'm going to do it in this file just to save time. All right, so I'm going to rotate my view by 2 points. And let's say in our projects here, we have an area that we want to create a clip terrain. So I'm just going to go to the drawing. I have different options to draw a shape. I'm just going to do a polygon. All right, so say we have a shape like that within our project. I'm going to use this shape and create a clip terrain. And then I'm going to apply a surface template to that terrain once I have that. All right, and at the same time, I'm going to do in this file, but the right way we do it would be in a different file, its own separate file. So maybe this is a model existing, unsuitable, and within the name or whatever naming convention that we have. So I'm just going to do it in this, but just for this demo here. All right, so we're going to come in and we're going to switch to our terrain tab. I'll go to the create group. We're going to go to additional methods. I'm going to create a clip terrain. Right, and this is part of that existing features workflow. It's just without the tool. We're going to create a terrain. We're going to go external to our existing. So I'm going to select on my surface existing. Do I have that twice in there? Let me look to see what I did. I'm going to detach that survey. All right, so before I attach the survey, I haven't ruled anything off that survey terrain. So this is still my active terrain that's coming from my GDTM. As long as I didn't snap or rule to that, I'm okay to detach that, right? That terrain model. But if it was ruled to or had a dependency on something in this file to that other terrain, I would have got a warning that I'm going to break those dependencies. I don't want to do that. But before I create another terrain, that's why I was seeing 2 terrain models in that, because I know I attached the server RD or the survey file that had an existing terrain model in it. I want to make sure I'm using my GDTM terrain model within there. Right? So I just didn't want to create a rule to that other terrain and confuse and get confused myself about it. Right? So we're going to use this shape and our terrain of surface existing to create a clipped terrain. So I'm going to go to the terrain tab on the ribbon, create group under additional methods. We're going to create a clipped terrain. Now, if I look at my list, I'm going to go ahead and pick one of those, or I can pick my terrain. I'm going to set my feature definition. Maybe this is existing, and this is DTM existing pavement. And I'll do this as, let's just say muck. So this is a muck area or unsuitable. Let's name it unsuitable. So we're going to create that with DTM existing pavement. It's going to create that terrain model within our workflow that we have. So I'm going to locate my terrain model, surface selection. I clicked here. I'm going to locate my shape. I'm going to right click and then left click through. I don't want offsets. I'm going to create that method. It's going to create that terrain model for me. All right. So if I look at this, there's my terrain model. It's unsuitable. So I'm going to apply my surface template to that terrain model. And this is going to, and I can apply the earthwork to this will be another subsoil excavation. All right, so I'm going to look at this. I'm going to come back up to my terrain, but now I need to go to model detailing. I'm going to go to 3D tools and apply a surface template. We're going to apply our surface template here. I'm going to pick our template. And I'll do to our existing feature templates. We're going to pick our pavement asphalt existing. I already copied another one and made it unsuitable. So I'm going to pick here. If I look there, it's not going to find that feature definition, but maybe I want to come in and copy this one and rename it. I'm just going to use the pavement asphalt existing. So in the template library appears, I don't want to replace this one. I want to add into it. So I want to come in and copy that, but I'm going to apply this one first, and then just like we did before, we're going to change that feature definition. So we'll see what feature definition is getting applied by this pavement asphalt existing. So we're going to go ahead and use that pavement asphalt existing. Click OK. We're going to disable linear features. We're going to locate our terrain model that we just created. So our existing feature pavement unsuitable. I'm going to left click, and then data point and left click, and it's going to apply that material, or maybe that's a unsuitable or a muck area that we're going to use. So now that we have this applied, we're going to go back over to our open run standards, expand out our standards or our model. We need to look at that feature definition, right, that this is using. All right, so it's back to our asphalt. We can check that one. We can go back up to our corridors, tab on the ribbon, up to template. We're going to go back and create template. I'm going to look at my pavement asphalt existing. I'm going to double click on that to see what it's using. It's using pavement asphalt existing from the mesh cross sections existing. Right? We could point to substrata, or since we don't have a feature definition for it, what do we need to do to next? So this is going to be unsuitable, right? So we want an unsuitable feature definition. But I wanted to make sure I know which one this is pointing to. Right? So if I close out of this, I'm going to close here. Can somebody tell me what the next step would be if we want to classify this terrain model? Instead of being pavement existing, we need to have it be pavement existing unsuitable. What would the next step be?
So you've changed the existing mesh from existing to unsuitable.
Do what, Michael?
So we will change the bottom option from existing to unsuitable.
We could, but we don't want to mess with this one. We want to make sure, so just like we did here, we would probably copy this.
In that case, we have to create another, just make a copy of that and call it unsuitable.
Exactly. Yep. Yeah, exactly on that. So it's within the volume option that we want this to be set to unsuitable. So exactly right, Michael. We would copy this. We're going to rename that to unsuitable. All right, so now we have unsuitable. We're going to make sure that's active. We're going to set this to unsuitable. We're just going to remove it, but we could do that split as we talked about if we need to remove and replace it, where this is just something that's going to be completely removed on that. And if we could set that feature definition in there, right? So now that we have this unsuitable and that's set to unsuitable, we need to change feature definition. So that's why we would come up here. And let me make sure I'm doing this right. All right, so I'm going to go back to my templates. I'm going to go to create templates. So the corridors tab, create group or template. I'm going to create template. And here I'm kind of getting off my own list. But we would come into our pavement asphalt existing. I'm going to right click on that and copy. And then I'm going to rename that to pavement asphalt existing. I already have it set up in here. And then I'm going to change this one at the component level. I'm going to point that to that new pavement asphalt unsuitable EX that I made. Right. So we don't want to override this one, but we want to override, create a copy of this, rename it to unsuitable, and then our component that we want to point that feature definition to our pavement asphalt unsuitable EX that we just created here. All right, so now that we have that, we're going to come back to our 3D view. I'm going to go in here, I'm going to change that template that we're using. So I'm going to go and change this from pavement asphalt existing to my copied template that I create to the pavement existing unsuitable. And that's going to give that to, or make that be an unsuitable feature definition that we could apply to that. Right, so now if we come back here, that's our unsuitable. It's pavement asphalt existing unsuitable. In this one, I'm going to turn off my default. So whenever you apply a surface template and that disable linear features, it's always going to have a container thing set on the default level. So I need to come in here and I'm going to turn off my default view. That'll allow me to grab that template, and then I can come in and make sure I'm grabbing that template and it's on the correct feature definition of unsuitable. Okay. So now I have this. I'm going to come back and attach that item type back to this element as well. So there I'm going to have my substrata that I'm going to build on top of, and then I can have my unsuitable material that I need to remove. And the nice thing about this is it's tied to this shape. So if I need to kind of widen this out, that terrain model is going to follow it and expand on there. So it's just a microstation shape that I have here. It's ruled, the terrain model is ruled to that shape as that clip in there. So I can come back and change that. I can then come to my utilities and I'm going to attach. I'm going to go back to a roadway cut. This is going to be cut. I'm going to apply that to my unsuitable. It says it attached it. And now I can come in here and I can do subsoil excavation and give this of just unsuitable. And I'll say And put in a construction note or design notes that we want to build that out. Right, we're doing this just so we can quantify that information that we have in there. Right, so I'm going to hit tab and run that. So now we have everything on our feature definitions. Right, we have our existing pavement. We have an unsuitable area. I know it falls out the project, but I just kind of want to show that we do that. So the next step that we would want to do now is we want to take a look at our template. We're going to build another model, which is going to be our US 98. We're going to apply that template to this. But we're going to look at our saw cut lines that we have here. Is we need to look at that template. So I'm going to go up to corridors, our create group and template. I'll go to my create templates. We're going to go to the examples for training folder. Hopefully everybody has that with the data set that they downloaded. We're going to go to our design and 3D modeling course guide. And we're going to just pick our, it's the 3R98. I'm going to double click on that. All right, so we're going to apply this template to that. But what I want to do, because we want that saw cut line for existing, we're going to look at this template to see what that is using. All right, so this is using a horizontal feature constraint of pavement milling and pavements. We're going to put in that just to mimic this feature definition. So we want to use that, and we're going to allow our template to widen out or contact or target our cut line. So we're going to build that at 10 feet out. But we're going to use this pavement milling ML line from our linear roadway design plan and profile 2D lines, pavement and milling. All right, so I'm going to go ahead and close my corridors. I'm going to, in this file, I'm going to go ahead and look for that feature definition. So I'm going to go to roadway design, we'll go to plan profile 2D lines, go to pavement. I'm going to pick my pavement and milling. I'm going to go to the geometry tab on the ribbon, horizontal group, offsets and tapers. We're going to do single offset partial. And we're going to set this offset to 10 feet. And I am going to mirror off the center line. So I'm going to use my center line. Doesn't matter to which side because it's going to mirror it off. So I'm going to draw that in and just place that line that we can use to target. So those are going to be external references that we're going to use on our next model or design. We would probably do this in a DSGN-RD file and reference that into. I'm just going to try and save time. To put that, again, we're just kind of showing the tools that we can do within there, right? So that's kind of the modeling that we have for existing and an unsuitable area, right? And we attach the item type to that so we quantify it. We did set those in there. So if we just want to check what's in there, some of the reporting tools before we get into our US 98 model is if we go to the Home tab and under the Model Analysis and Reporting group, we can go to our Civil Analysis tools and we could do Element Component Quantities. This will allow me to select multiple corridors. So we only have one corridor here, so I'm going to go and right click, and that will give me that total that we have for our substrata, right? In the surface area and the cubic yard. That'll give me a quick estimate of how much that I have, and I can set a unit cost on that to see what that quick cost is. I can also click on the reports here and see that summary report. Right, so that'll give me a quick estimate of my corridor for the volume. I can set the unit cost of how much that's going to use or save if I keep that material in there. Right, if I wanted to adjust unit cost, I don't know what existing payment, maybe it's 55. But then that's going to adjust, and I'll look at that report, that's going to adjust as well. So again, that'll give me a quick estimate of how much that volume of that existing substrata material I can keep in there. Right. I could also come in and the home under corridor reports, we have component quantities. That's just going to look at the components within there. I only have, and look at the cut and fill as well. So there's my cut volume. It's going to be same as my substrata. So those two volumes are the same. I can look to see how much that is going to be. This is the component quantities. And I can look at that report, adjust those unit costs as well if I need to. All right. And then the last one is our quantities report by name boundary. We can use that even though we don't have a name boundary defined. It's going to look at that entire file if I do that. So if I had name boundaries, this is where I could mimic cross sections at the different intervals. I could do phasing and build those out. I can lay out a name boundary just to mimic that, either cross section or phasing on the left or the right of the or north or south. If I don't have a name boundary, I'm just going to click it. It's going to give me an overall report and look at of the file. And there we have two different materials. So substratas are pavement existing and are unsuitable. It's going to give me those two areas and the volumes within there. Okay. If I build that out and add that more, that's going to give me my quick reports that I need to report on that information in there. All right, so that's just a couple different ways to build out some of those existing features. That's all alternative to your create existing features. So just, and based off of the different feature definitions that we have and ways to quantify that earthwork in different ways. So our next file that we're going to create is going to be our US 98, and then we're going to reference this file in and run those same reports. And that, I think, should take us pretty close to time. I'll try and see if we can open it up to questions if you guys have, if you have specific projects that you're thinking about too. We can talk about those now. Next week, we'll have a follow-up. So if you have questions that you don't think of today, have something afterwards. There is a 2-hour session that you can bring a project. We can work through a solution or look at that as well next week. Okay, so we're going to go to our FDOT tab, our actions group. We're going to create a new file. I'm going to create our model. This is going to be our, just do _ demo. This will be, oops, say 3R in US 98 and _ Okay, so this is going to be our demo for the 98 that we're going to create. So I'm going to create and open that file. We're going to reference this file in. We're also going to reference in our alignment and our GDTM RD file and set that as active. Okay, so now that we have that file, I'm going to go to my references and attach. I'm going to attach our demo, our alignment 2 or the alignment file that we're using. I'm going to add those. So I'm going to click that little caret. Oops. I want my demo, so I want to add that one. I'm going to go up one and grab my survey, grab my existing ground, add that in, and open. And this will be our ALGM, BR, ML, BR, MO, and my GD, TM. All right, so I'm referencing in everything that I need. This is going to be for my US 98. I'm going to fit view. Go ahead and set that terrain as active. I'm going to right click, go to view control, go to two views, 3D, or plane and 3D. Come back to my view one, and I'm going to turn off my 3D view. So I'm going to go to my levels, turn that display off. I'm not seeing any of that 3D information in there. And then I'm going to go ahead and apply our 3R for 98. So we'll go back up to our corridors tab. Create group, we're going to go to corridors. And we're going to set that to final. I'm going to locate my alignment. Reset for active, it's going to be US 98. We'll do the 10-foot increment. I'm going to come in and grab my template. So I'm going to go up to examples for training. Design 3D, I want to pick that 3R. I'll apply that. I'm going to set that to 18 plus 50. And the end station is going to be 21 plus 50. I'm just going to left click through. It's going to be the same extents that we have. I'm going to hit escape. And there we have our template, and we're outside of our existing. That's why we put our milling lines. So we're going to do our horizontal feature constraint on our corridor, and we're going to target these two lines to widen that out for our surface. So I'm going to go back up to corridor references and in the miscellaneous group. We're going to go to corridor references. Go ahead and locate my corridor for US 98. Locate my reference, right click, and that's going to widen that out. Right? And then it's going to mill on top of our substrata that we have in there. Right? So now that this model that we have, we can apply or do our QTSRD file and get those reports and create our cut and fill volumes within there. One thing that I did notice on this though is before you create your cut and fill volumes, we always want to double check our feature definitions, right? And I did notice in the milling and the overlay that we have within the workspace on those mesh components, those are not set from the feature definitions. So if I go to my Explorer and OpenRoad standards, I'm going to go to my model because everything's got written into there. I'm going to go to my feature definitions and the mesh. We'll go to cross section. So this is all our design. So I'm going to just double check that these are set to design. We're only going to see the elements or the corridor that we have in this file. Right. So I'm just going to come in and double check on all these elements in there. But if I look at milling, right, that's set to none, so that's going to ignore it. That could be right, but in the milling, I want that to mill down, so I'm going to set that to design as well. Right, and then I'm going to look at my overbuild. I'm going to set that to design as well. So that might be something that needs to be set on those components of milling, overbuild, and overlay. We need to make sure that's, if by default, is it supposed to be set to none, or do we want that set to a design? So it's going to look at that bottom mat, because that's going to mill down a certain depth and provide those overbuilds on there. My gut tells me that it needs to be set to designed, so we can help and build that information if we need to cut fills in there. If we wanted it to ignore those surfaces that are going to be set to none, it's not going to look at those. But if we have our milling and overbuild in there, at least overbuild, because you're going to build back up, right? Or if you're overlay, you're going to build back up. We want it to look at that bottom feature. So I just want to double check on these features to make sure that everything is set correctly for my model there, right? So now everything looks good. In the model, we can come in and look at our cross sections. So I set my terrain as active, that created our 3D. We applied our R template. So I'm going to come back and do a hard right click, do my view control. Oops, I'm going to do plan cross section 3D. Wait for my dialog to come up, click OK. I'm going to locate my corridor. I'll apply that, and there we'll see that. I'm just going to make this a little bit bigger in there. So right there we have our model. If I walk through that, I can look to see if there's our substrata. Here's our new, we're widening that out. We have our build. So there's our overlay component. There's our overlay component that's going to be, we can look in our dynamic cross section. We can turn on and display cut and fill graphics and the values. And then as we walk through, that's going to give us a cut fill. Notice that it's not going into that existing, but it is looking at that milling, because that's all cut and fill we're going to design. So that's all we're cutting down, and we're going to build that back into that cut area and fill area. So it's going to give us that quick information that we need in that dynamic. So it's going through and cutting to those bottoms. But since we set this to substrata, it's going to be quantified, but it's not treating it as a cut or fill. It's building on top of that information in there. So we turn these back off. We can run through and see, right? If we moved our corridor up here, we could see what it's doing up here as well. So there's the two different areas of kind of the different scenarios of how we would build and tie that together, right? If we had an unsuitable area, we'd probably want to model that separate than our substrata area, but that's going to quantify in our reports everything that we see within this file if we create that Qt SRD file. And then we can build from there our Earthwork reports that we have. Right? So if we come here and we look at our quantities report by name boundary, we don't have a name boundary, but it's going to look at everything in this file. And now it's going to look at every corridor that we have. So this is our existing. And we'll also see our unsuitable and substrata, and then all our proposed model information in there. All right, so we have that information in here that will give us a quick, that's the quantities report by name boundaries that we have in there. So that's some of the workflow, or of introducing Earthwork and really looking at your mesh options of the feature definition and what they're set to for us to help quantify what we need down the road in there. Right. So we looked at quantities report on name boundary. That next step would be to take this file and reference this in to a QTSRD, and then we would come in and under a model analysis, we're going to create cut fill volumes. We have unsuitable, so we want to check that box on, and we want to check the substrata on as well, right? So that's what we're going to do next is we'll reference that file into there, we'll run it, and then we can run our quantities. But any questions on any of that? Was that way too fast? Way too much information? So, and we have, unluckily, these are being recorded, and you can review them as well. So all the information in there that we can review on there. But if we come back in and we'll create our QT SRD. If I can bring that up, we might be close to quitting time. If file does not open, so there is my QT. We'll just do this R underscore. This will be our demo. We'll just do EW. Right, so we're going to create this file. We're going to reference in our existing pavement, our US 98, all the demos, our alignment, and our existing ground. So we'll open that file up. We're going to go home, primary group, and attach tools. We're going to attach. And we're going to grab our demo, our alignment. I'm going to add, go back to survey. So I'll go up one, grab that survey, grab my existing ground. I'm going to add that as well. Do ALGN. My model. My model and GDTM. Right, the logical name is optional, but it helps you kind of sort through some of that. Right, so that we have that information in there. We're going to come in and set our terrain as active. Right click and view control. And we're just going to do two views, plane and 3D. We have everything in our file that we need. Right, so we have our unsuitable material or substrata or proposed. Everything in our feature definition, those meshes are set correctly. So now we're going to come up to the Home tab, Model Analysis and Reporting, and we'll come in and create our cut and fill volumes. And we're going to compute unsuitable, and we're going to compute our substrata. And our volumes of cut, we'll just make sure that we have those. Right. Set. Right. And that's going to run through and create. And there is our meshes, right? So from here, there's my earthwork. And I may have to get out back in, but I'd want to set those on both of those. My cut and fill area on there, the earthwork, so that item type, because that item type's already going to be on that item there. But now if we look at that, it's not going over that substrata. It's creating that cut outside, and there's a little bit of cut on top as well, the sliver that we're doing our milling and overlay. that it's going to build back the overlay. So we have a little bit of cut that's going to come out because we're milling down, and then we're going to overbuild, build that back up within that information. So let me get out, and I want to get back into my demo. Just because my property is not looking, and we're going to set our item type on our earthwork and our fill, and then we can run that report, and I'll quickly show those name boundaries that we have, the name quantities by name boundaries tools. Right, so I'm going to jump back into my file. And we'll see how is everybody doing. Everybody still good? The diehards that are still on?
Still good.
Okay. A lot of information.
It is a little fast, but it's entertaining this way.
Yeah. All right, so I'm gonna let that get back in and go back to my view control. 2D and 3D. I'll come back in and grab all right. So that's the cut. That's gonna be regular excavation. Then let's see, do we have any? We should have some fill as well. Maybe I did a better job on that one. That we're not seeing that fill. But now that I have right, that should be able to come here. And my takeoff, I want to create earthwork. Open up that file. I don't have it open. And compute. And there is my subsoil. So I'm just missing the one in there of subsoil. So it's here. So I just didn't put any design notes. So I don't have any fill in this situation or that pay item number. So I think that's 126 for fill. But everything would show up in this report, and then I could use that to create that other one. Right. And some of this stuff may vary depending on how we built some of that information, but it's going to give us those quantities based on the item, given the ID, and how we're kind of building that. Okay, so there we have those. And then the last, in this file, if we want to make my plan view active, and I turn off my 3D view. And I don't, probably not supposed to make the name boundaries in here, but I want to show that tool. So if I come in here and go to drawing production, I'm going to place name boundaries within here, but I'm not going to create my drawing or show dialog. I'm just going to create the boundaries for my US 98. Right, so I can come in here, and if I pick my 11x17 plan only, I can then come in and adjust the offsets. So say we want this to mimic 50-foot cross sections. I can do 50 foot. Say we want negative 120 or 140 and positive 140. Right. So we're going to mimic cross sections with our plan view. So we can get our report by name boundary. Right. So if we had phasing, we could do the left side of the roadway or the north side as well. Here we're just going to mimic cross section as our plane group. So I'm going to set that to 50. Left offset's -140. Right offset is 140. And I'm not going to create drawing or show dialog. I'm just going to come in here and I want that. Right. We did 18 plus 50. I'll run that to 21 plus 50, just for example. Right. So I was going to create our cross sections or our name boundary that we can use. So now if we come up to our name boundary tool, civil analysis, and we can look at quantities report, we're going to see everything, since we have these, are mimicking cross sections. So it's only going to look at the information within this name boundary. So I'll do quantities report by name boundary. I can pick my name boundary. This does display clip graphics. So I had clip graphics in a file. It's going to bring that in and I can utilize that and see those clip graphics in there. So if I had something clipped from another corridor, it's going to bring that in. If I had an item type on that, I would see that information in this file. I don't have anything, so I'm not worried about that. But I'm going to run my report now. And we'll notice, right, that's going to go from 19 to 1950, right? And it's going to have everything in there as a cross section. So it's going to look at everything within the station range and give me those quantities on there. If I come in here, I can go to the format options. I can convert to cubic yards, close, there's my 19 plus 50. That'll give me everything in there that I can use to, do a quantify or check that information as well. All right. So that's quantities. We did earthwork. We did alternative ways of displaying. Did element component quantities. So if we look at our mesh components as well, right, another way to look at that. Our civil quantities, we can look at those, that reporting on and report on that information in there. So that, for the last 3.5 hours, sorry you had to listen to me. I know it is a lot of information. And yeah, hopefully you guys got something that's a little bit more than just a normal training, but it's a lot of information in there. If you guys do have questions, I can open up for questions now. If you have something on a project that you want to bring and talk about, we can talk about it now or even next week. I think on Wednesday from 9 to 11, Brian sent that out to the same group. If you have something specific on a question or a project question, we can look at that as well. But I think that is all I have for you guys. Do appreciate hanging out and sticking with me. I know 4 hours is a long time to do training. Thank you for the staff for giving the opportunity to come and share that knowledge. If you guys have questions, let me know. Chris or Matt, if you guys are still on, or Mike, is there anything that I missed or you want me to cover or clarify from FDOT side?
I think that was fairly thorough.
Cool.
Chris, do you have anything you'd like to?
Nope. I think that was, yeah, did a great job, Todd. And I think, I think everybody's a little just kind of taking it in. So probably do questions next week at the follow-up, unless anybody has anything right now.
Great.
I know it is kind of late in the afternoon.
It is. So I think the other ones are towards the morning. So, but yeah, even if you guys do jot something down, come back with questions. happy to help you guys out and figure it out. And again, if I can't figure it out on a call with you, I can research it a little bit and get that other information to you. So. All right.
Thank you again, Todd. Matt, do you want to
Yeah, I'll go
handle
ahead
the
and close
recording?
this out. Sure, yeah, I'll have the recording done. I should be able to download that shortly, and it should be available sometime tomorrow. And I'll give that to Chris or whoever, and we'll figure out where to post that so that everyone can refer to that. And that might help to also inform some of your further questions.
Yep. All right. Well, thank you again, guys, for joining us. I look forward to the questions that come next week, and I think the future topics too for what is it, the triple R projects, templates. Now that we kind of know what's going on with those, don't be shy. Think of it as kind of maybe stumping the Bentley employee too. So happy to help and figure stuff out. That's part of my job, is to get that and share that knowledge and help you out. If I can't answer it, I can reach out to a couple colleagues and have them help me out too. But we are here to help you guys and support you any way that we can.
Very much appreciated there.
No problem. All right. Well, thanks everybody.
Thanks.
Thank you. Have a good one.
Thanks, guys.
Thank you.